some information about the water before the chemical reaction happens. So I'm just turning on the thermometer, taking the temperature of the water. It's all very, very, very simple. And of course,
Lithium.
we're going to start with lithium.
Alright.
So where's lithium located on the periodic table?
We have to get
It's the second one.
when you
It's in the second row. You're absolutely right.
Good work here, good work.
And our videographer doing a very nice job.
Is Brian Campbell. Oh, yeah.
Okay, the water is
yeah.
32.3 degrees Celsius. So prior to the reaction, the water is 32.3 degrees Celsius. Record that on your page.
It's like boiling, right?
It's like, no.
just tell me when you're gonna blow it up. Like,
I will tell you when I'm going to blow it up, I promise. This is a...
Anyone in the stream loud, is it?
I'm sorry, Ryan.
Yeah, I do.
Hey, if I was the video guy, would I not have had to do this?
Yeah.
And Ryan, you can just copy up something.
Me? You.
So this is a conductivity tester. And we look at this and what happens to the lights when I take
Bright
the
red.
It's red.
Okay, is it bright red or just bright red?
It's like Rudolph
Bright
red.
Is the green light on at all?
No.
No.
Alright, so we have some red and we have no green light. And I look at the back right here and it says red, and this is and no green, dim, low conductivity. So you're writing low conductivity for before the chemical reaction. Would you letter E? Letter E?
Letter E. Oh.
Letter E.
Low.
And then we're going to take the pH of the water before the chemical reaction. So just take a piece of pH paper, dip, 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 dip. And it's contaminated. That's not a good thing.
It's contaminated.
It is. So we dip.
Science, it's a good movie.
And then we're just going to match up. To match the pH, we match the color. And what do we get for pH?
last one.
6.
12.
It's not a 12.
Okay, that's
15? 26?
6 or 5?
6.
Okay, so you're going to record your pH as 6 for before the chemical reaction.
This thing's just a bad thumb ring.
Bad what?
This is my thumb ring. Bad. Not comfortable.
Okay, we're filming.
Alrighty. So this is lithium. It is the element lithium, which means that it has the same number of electrons as it does protons. Stop throwing things.
Yeah, this is serious.
It is serious.
Pen.
And they store this in mineral oil. It's really goopy. And the mineral oil puts a coating on it that protects it from the air and from the water that might be in the air. So I'm just going to take this really funky, lovely scalpel, and I'm going to cut the lithium in half and expose the front part of the lithium so that you can see it. And if you look inside, it should look like a metal to you. It's nice and shiny.
Oh, yeah.
How did you cut that?
It's a really soft metal. It's not like silver or gold. You just can put it, it's very soft. So you see it's got luster, which means it's shiny, and it was malleable, meaning I could bend it with the scalpel.
Yeah.
That's not the name.
Alrighty, now here's our first chemical reaction. We're going to
Wait.
put our goggles on.
Wait!
Okay, this one doesn't explode. You're safe. I
Oh
promise.
man, buzzkill.
Okay, and we're just going to watch what happens to our lithium as we put it into the water. So what observations are you making that's saying a chemical reaction's taking place?
Bubbling.
Bubbling and smoking.
Okay, bubbling. You see smoke coming off. What do you hear? You
Fizzing.
hear fizzing. All right, how do you know that this is an energetic thing that's happening?
Because it's moving.
All right, it's moving. It's moving around the surface of the water. So we know that there's energy that's being released. Energy, 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 energy.
Yeah, it's crazy.
It's crazy. Bubble, 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 fizz, 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 happy, 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 joy, joy, joy.
Happy, happy, true.
And as this is taking place, what exactly, from the notes that you just took, what exactly is happening?
The temperature is rising.
Okay, but in terms of redox, what's happening?
Oxidation.
Oh,
Oxidation, yes, Abby, oxidation is happening. Yay! So in the water, the lithium,
No, if you just...
she got it. So the lithium is giving away its valence electrons. It's giving it away. And so just like Abby said, oxidation is taking place. So now I'm going to take my lovely, lovely thermometer, and I'm going to take the temperature again after the chemical reaction. And it's going up, and it's going up, and we're over 40, and now we're over 42, we're over 43, over 44,
Over 45.
almost
In a minute.
to 45,
45,
45, over 45.
5,000.
So what kind of an experiment or what kind of a reaction gives off energy? Anybody know? 45.3. 45.3. What kind of reaction gives off energy?
A chemical reaction?
Yeah. Chemical reactions can either give off or take energy. And this one, how do we know, first of all, that it gave off energy?
The temperature went
you
up.
could-
Temperature went up. Beautiful. Temperature went up. So we know it gave off energy. And then, here we go. Exo means like an exoskeleton's on the outside or give away. Endo means we're taking it in. So this is an exothermic reaction. All right, now, here's our pH paper. What happened to our color? It was a 6, and now what is it?
11.
It's an 11. Okay, so we went from a 6 to an 11 in pH. Awesome. And finally, we're going to look at our conductivity. Remember, it was
Green.
low conductivity. Now, what do the lights do?
Same.
Extremely bright and then
It's
there's
extremely bright, and is the green one on?
dimly.
A little bit, yeah.
Okay, so now we went from low conductivity
To high.
very high conductivity. Low to very high. Excellent. So that was lithium. Lithium, again, is in the second, it's the second period, the second row of the periodic table.